Thank you very much for taking the time to attend this latest installment in the Interacoustics Academy webinar series. The title of this session is to provide an introduction to the rotatory chair. Now, we have here just a brief introduction of myself. So my name's Mike Maslin, and I'm a member of the Interacoustics Academy, and we're a team of audiologists who provide training and education in all of the various different audiological and vestibular applications. So I'm proud to present today one of those topics, which is in the vestibular domain, and that's of course the rotary chair. So we have a number of different intended learning outcomes that I wish you to take on board as we move through the session. First of all, we'll go through to an introductory level some basic principles of the chair. There are 3 subtests. That's the sinusoidal harmonic acceleration, the velocity step test, and VOR cancellation or suppression test. So we'll just talk about the underlying principles for those tests, and then we'll move on to something a little bit more applied via the use of video demonstration and a case study, just exploring clinical applications of these tests, these subtests of the rotary chair, and how it fits into the wider scheme, the wider vestibular test battery. Now, what we have here is a schematic on the left of the screen, just a kind of a top-down view of the labyrinth. That's the vestibular labyrinth, which is the part of the ear that's responsible for balance. And if we draw our attention to the schematic on the right side of the screen, then we can see that there's an interesting division of labour when it comes to providing the sensory input that we use to maintain balance. So the 2 sub-organs on the very right hand side, that's the saccule and the utricle, these provide a sensation of linear acceleration, of tilt, of up and down, a sense of gravity, so linear acceleration, whereas the 3 semicircular canals, the anterior, the lateral and the posterior semicircular canals, the 3 that are approximately orthogonally orientated relative to one another, and these provide a sense of angular acceleration. So we have this sensation in all three dimensions, the X, Y and the Z plane, and so the ear physically decomposes the accelerations, both linear and angular, and then codes the individual accelerations that is then reconstituted by the central nervous system to provide a code, an ongoing neural code, which the brain uses for maintaining posture, for changing or dynamically modulating posture as we move through the environment, and also for correcting the position of the eyes in their sockets as the head moves, so that we have a stable visual scene. And when there's a deficit in these vestibular organs, and of course to some extent the neural connections, the reflexive pathways that constitute the balance system. When there's a deficit, then we have a reduced ability to maintain posture and dynamically alter our posture as we move through the environment, and also to maintain a clear visual image. And so people with a vestibular deficit, when they move their head, they may well complain of a symptom of oscillopsia. That's the blurring of the image as they move their head. But it's these reflexes that subtend between the ears and the eyes that we're most interested in today. And as I mentioned, there's a rough division of labour whereby the utricle and the saccule provide input that constitutes the linear VOR, vestibulo-ocular reflex, whereas the semicircular canals, they subtend the angular vestibulo-ocular reflex. And you might take from the title of the session, the rotatory chair, that we're talking about some kind of angular stimulus, and so it's the angular vestibulo-ocular reflex that we're most interested in today when it comes to this particular test. What we have here is a schematic of the angular VOR, the VOR that is driven by the semicircular canals. And of course there are three, as I mentioned, the lateral here, as well as the two vertical canals. And when it comes to diagnostic testing, then the lateral canal is the most commonly tested, because it's one of the reasons why is because it's the easiest canal to provide a stimulus for. But what we have here is we can see that if I just get my pointer, we can see that we have the peripheral end organ on each side, as well as a range of different neural connections in the brainstem, and then the extraocular muscles that actually control the eye's position. And what we do when we're interested in measuring the activity in the VOR, and specifically when we're interested in the sensitivity of the ears to a head rotation, then we will use a infrared camera equipment instrumentation that can track the eye movements, and we will infer from the particular pattern of the eye movements what the input from the ears to the VOR may have been. And in this case, with the eyes are maintained in a stable position in their orbit, so they're held gazing forward, and we have here just a schematic of the sensory epithelia, the hair cell on the right and on the left, and these spikes here, they represent ongoing or tonic activity, neural activity that provides a tonic muscle contraction in these extraocular muscles to hold the eyes in place even when the head isn't moving. And over here we can see a picture of that schematic of the instrumentation that we can use, video oculography, to track the eye movement there. Now, there are a whole battery of different subtests in the wider vestibular test battery that we can use to stimulate and then test the angular VOR. So traditional and very well-known test is, of course, the caloric test, and we have that displayed on the right here. We have a patient in the caloric test position as they lie back, and we would use our instrumentation here to track the eyes as we changed temperature in the ears. And by changing the temperature, one of the things that we'd do in the horizontal semicircular canal, the lateral canal, is to set up a temperature gradient between one side of the canal and the other, and then that causes convection currents, which either, if we heat the fluid up here, will cause the cupula to push towards the utricle and cause an excitatory response, or we could of course cool the ear down and cause the opposite convection current and then the opposite response. And the caloric is of course a centerpiece really of the traditional vestibular test battery. It's the gold standard, you might say, for unilateral deficits, because it remains the only true test that's ear specific, selective to one ear or the other, because we change the temperature in one ear at a time. Then of course we have the rotary chair, and that's the main topic of today's discussion. And this has a number of advantages over the caloric test. And so the two tests are very much work hand in hand. It's not that one is necessarily better than the other, but they work in a kind of partnership. But one of the main advantages of the rotary chair over the caloric test is that the stimulus itself is a very carefully calibrated and stable stimulus. That's a rotation of the chair. The caloric stimulus, well, we calibrate the fluid that goes into the ear very carefully in terms of the temperature and the volume and the flow rate, but the actual temperature gradient that we set up across between one side of the semicircular canal and the other, that's uncalibrated, and it's because the efficiency by which the temperature change that we put in the external canal here transmits through to the inner ear will be different from one patient to another. And so, for example, anatomical differences either between the ears or from one patient to another can mean that we have a calibration error, an unknown calibration error. Whereas in the rotary chair, we spin the patient and their head is firmly attached to the chair, so the head rotation and the chair rotation are stable and finely correlated. Another advantage of the chair over the calorics is that it's generally more well tolerated by patients. The caloric test does tend to make patients feel rather unwell. Sometimes they even get to the point where they might vomit, but that you might expect to be relatively rare in the chair if at all. And the other major advantage over the caloric for the chair is that the speed of the rotation it's a stronger stimulus, so we can we imagine that there's a greater possibility of a greater copular deflection, a stronger stimulus that we can apply. Now on the right here is the V-hit, and the V-hit here is perhaps the younger of the three key tests here that I'm displaying. Tests of the angular VOR, and it has a relative advantage in some sense over the chair in that, of course, it's cheaper, it provides a stronger stimulus again than the chair. The manual head rotation that you can achieve with the V-hit over the chair, and there remains the possibility of testing all 6 canals, so you can rotate the head in the plane of all 3 pairs of semicircular canals. But on the other hand, nevertheless, the chair, when compared with the V-hit, well, you might say that the manual manipulation compared with the computer-controlled chair stimulus, that the computer-controlled stimulus means that there's no issues of technique, which remains to some extent a pitfall of V-hit. The contraindications that might come up from time to time that might prevent you from doing a V-hit, such as neck trauma, unlikely to apply in the rotary chair. The goggle slippage issue that sometimes again remains a challenge in V-hit is much less of an issue in rotary chair, and because it's been around a lot longer, it might be fair to say that there's a much wider evidence base, so certainly for important details such as normative ranges specific to different populations and so on, it might be reasonable to suggest that that's more established in the rotary chair literature. And another key issue I would suggest is that with the rotary chair, the eye movements are assessed with the patient in darkness, so then there are no issues of fixation, for example due to eyesight issues, gain changes that you sometimes get from wearing spectacles. That can be a feature or factor of the video head impulse test, but because you're in darkness, it shouldn't be a factor in the rotary chair. So there are a number of pros and cons, and the main take-home message therefore is that there's no one test which is standout, but they're all very much working synergistically with one another. But of course, we'll just move on now to just focus on the chair. Now what we have here is a slide that crops up from time to time in these sorts of discussions, and what we have is on the x-axis the speed of the head rotation moving from left to right. The speed increases, and on the y-axis the VOR gain, and a gain of 1 at the top of the y-axis would be that the VOR is working perfectly. In other words, when the head rotates in one direction, the eyes rotate just the right amount in the other direction to maintain a stable visual image. And you can see that in the very low frequencies, the VOR gain is less than 1. So the eyes will not perfectly rotate with the head. In the medium frequencies, where the rotary chair and the V-hit subside, then the VOR is around about 1, and then in the high frequencies, the performance of the VOR reduces again. So this is a very useful slide for contrasting the different tests that we have available, and the rotary chair sits in the middle there in terms of its ability to test the VOR at or around the optimum speed of the head rotation. Now, just as a brief aside, because I just wondered if it may have crossed your minds as to what tests we have that look at the linear VOR. And so we have on the left here, we have the OVEMP. So this is sound which is introduced to the inner ear, and it causes a deflection of the otolith organs, the utricle and the saccule, and we can measure muscle twitches electrophysiologically from the extraocular muscles that drive the VOR or underlie the VOR. So we can test the linear VOR that way. We have the computerized subjective visual vertical. So this is a relatively new feature. The patient or the participant sees a line, and they might tilt their head one way or the other, and the objective is to orientate the line vertically, and if there's an asymmetry in the linear VOR, then their ability to do that task will be impaired, and we know that it's the VOR because it's a visual task. So it's the VOR that we're testing, and similarly we can take our VNG goggles there, and that's the head heave test, and what we can do is in a manner very similar to the V-hit, where we rotate the head, we can do something very similar, but instead of rotating the head, we can shift the head from side to side in a linear fashion and observe the same sorts of features, so gain and whether or not there was a saccade required. So moving on, we'll just now concentrate only on the angular VOR. And this shows us, again, just touching on what happens when the head is static. So there's no rotation of the head here, and what we have is a symmetrical pattern of neural activity that flows through the neurons of the vestibular ocular reflex to produce a balanced contraction of the extraocular muscles on either side of the eye, and we're talking about the horizontal semicircular canals, so that means the lateral rectus muscles that hold the eyes horizontally. So the eyes are held in position even when the head is static. And then what happens when there's a head rotation is two things. So on the right ear here, so this is a rightwards head rotation, as you can see from the notes in the top there, and a rightwards head rotation is sensed by the right ear, and that causes deflection of the hair cells, the stereocilia of the hair cells, such that we will get an excitatory response from the right ear, and this causes muscle contraction of the left lateral rectus muscles, while simultaneously the left ear will also sense this rightwards head rotation, but at the same time the stereocilia are deflected such that rather than an excitatory response, this time we get an inhibitory response, which is shown by these fewer spikes here, and that leads to a simultaneous relaxation of the right hand lateral rectus muscles. So we get contraction of the left muscles, relaxation of the right muscles, and then the eyes will rotate to the left as a result to compensate for the right head rotation. So that brings us on to what we actually do with the chair. So we measure this eye movement with the VOG goggles, as we show here, and what we do is we sit the patient in this mechanical chair, and as you can see, the cover is on the goggles, so we're measuring the eye movement with the fixation removed. And while we rotate the chair, that produces the rotatory stimulus, just like we were shown in the schematic a moment ago. During this procedure, the patient themselves are just asked to mentally alert. This is to prevent any kind of suppression, top-down, if you like, suppression of the vestibulo-ocular reflex. And we simply record the resulting pattern of eye movements, which is known as nystagmus, which I'll just touch on in a few moments. But the speed of the eye movement is then compared with the speed of the head movement, and the head-by-head movement, we assume that the head and the chair are moving together, so we measure the head movement simply by measuring the speed of the chair movement. Now, in terms of the setup itself, so these rotary chairs have the ability to lie flat or lie in the 30-degree angle, the caloric test position. But when we use the chair in the rotary chair sort of mode, then we would have the chair in its vertical position. And the head is bowed forward slightly by the use of this headrest. And this is because we're testing the horizontal semicircular canals. And normally when the head is straight, the horizontal canals are tilted upwards by around 30 or so degrees. But by tilting the head forward with the use of the headrest, then this brings the two horizontal canals, one on either side, into the genuine sort of horizontal plane. And then with the patient strapped in for safety and so on, we can then proceed with the procedure itself. And as I mentioned earlier, then there are sort of 3 subtests in the rotary chair test battery, and I'll just slide through them in this order. So first of all, we'll talk about the sinusoidal harmonic acceleration, then the VOR suppression test, and then the velocity step test.